Lesson 3-4, B Negative Exponents. Any non-zero number to the negative nth power is the multiplicative inverse of its nth power. So it's showing us a to the negative n equals 1 over a to the n. But I don't think that that is enough to explain it to you. I want to show you using an example and the technique we used yesterday. So you need to write a to the third over a to the fifth, and write it again, a to the third over a to the fifth. And I want to show you something. So yesterday we said that if you're dividing the same base, like the a's, you're dividing the same base, you subtract the exponents. So 3 minus 5, what would that be? Mason?
-2.
That'd be -2. Well, I want to show you this one. A to the third means a times a times a, and a to the fifth means a times a times a times a times a. When we have simplified fractions, we canceled out the common factors from top to bottom. So these a's would cancel, and wouldn't they leave ones in their place? Just like we did when we simplified, and this set of a's canceled, and this set of a's canceled. Well, if I did that, all of the a's cancel out at the top, and what's 1 times 1 times 1 for the top? 1. And on the bottom, I've got 1 times 1 times 1, and then a times a. What's a times a? A to the second power. So we started at the same place right here, but we ended in two very different places. A to the -2, a to the -2 is exactly the same as 1 over a squared. 1 over, or a to the -2 is the same as 1 over a squared. Now, I will tell you this. At the top of your paper, I want you to put an asterisk and never leave negative exponents. Never leave negative exponents. Now, there will be some problems in this assignment that says write your answer with the negative exponent. That is only to make sure you understand how to switch from one form to the other. But in a regular problem that you're solving, you never, ever leave negative exponents. Never leave negative exponents unless it specifically tells you to do so. Now, I will also tell you that the examples they give us, this one, 4 to the -2, you're going to have to do that. To simplify using a positive exponent, you would put 1 over 4 to the second. You will have to do ones like example 2, 1 over x to the 6th, right? Using with the negative exponent other than -1. Well, if it's in the denominator as x to the 6th, you write it without the 1 on top as x to the -6th. This last one I do have a problem with. It says simplify, and it's x to the 4th times x to the -7. Well, it's the same base, and you're supposed to combine or add the exponents. They left it x to the -3. I'm telling you, we would get that wrong. You never leave a negative exponent. So you might do that problem that way, but you would not stop here. And I want you to write this problem down. It says x to the 4th times x to the -7. We're not going to do this one, so don't write this one down. X to the 4th times x to the -7. Using yesterday's rule, it's x to the -3. But I'm telling you, you have to go one step further. We are not leaving that as an answer. How do we make that have a positive exponent, Liam?
You put x to the third over 1 over x to the third.
1 over x to the third would be your final answer. I'll make sure that I write that a little bit better. 1 over x to the third. I never want you to leave a negative exponent unless it gives you that in the directions. Okay, now let's look at some examples at the bottom of the page now. You were supposed to do these. Remember, we're leaving positive exponents unless it tells us specifically to do a negative exponent. So let's look at, and we're probably going to do most of these, even though I told you only to write the odd ones down. So we're going to start with number 1. Write each expression using a positive exponent. It says 5 to the negative 4. Eli, what am I going to write? 1 over 5 to the 4th. That gets rid of the negative in the exponent. Okay, let's do number 3. A to the negative 8. A to the negative 8. Dylan.
1 over a to the 8th.
1 over a to the 8th. Yep. Now, I'm going to do number 2. I know you guys weren't supposed to write it down, but to me, I'm thinking that looks way more difficult than what the other ones were. It says negative 6 in parentheses to the negative 7. The reason that the negative 6 is in parentheses is because it is negative. That has to be in parentheses because it has to say the whole negative 6 is to that power. So when you simplified this, please go ahead and add this one to your notes. You would have to write 1 over. That negative 6 has to be in parentheses because it was in parentheses here, but to the positive 7. Okay, write these using the negative exponent other than negative 1. So if I go right to number 5, it's 1 over x to the 4th. The directions say use the negative exponent. So what would it be? Emily? X to the negative 4. X to the negative 4. Okay, I know you didn't have to write 4 down, but I think it would be a great example. 1 over 5 to the 3rd. How do I write that with a negative exponent? Liam?
It would be 5 negative 3.
5 negative 3. Okay. I am also going to do number 6 because it is different than the rest. Do you see how this says write each expression using a negative exponent other than negative 1? Right now I see 1 over 16 and there's no exponent there at all. What did I tell you yesterday when there's not an exponent? What is really there? A 1. Well, we can't write a negative 1. So here's what you've got to do. You've got to take 16 and write it as another number to a power. Can you think of any number to a power other than 1 that would equal 16? Caden.
4 to the power of 4.
So 4 to the power. So 4 times 4 times 4.
No.
What do you think? You're onto something, I think, with the 4. 4 to the power of 4 to the power of 2. So here's how you do this 1 over 16. You'd say that's really 1 over 4 to the power of 2. Now, Caden, can you please write that with a negative exponent now?
Yes.
What would you write?
I would write 4 to the negative squared.
You are correct. That is exactly right. So they might give you some where you have to do a little thinking like that about powers. Question, Andrew.
Couldn't it also be 1 over 8 to the second power?
8 to the second power is 8 times 8 or 64.
Oh.
It could probably be 2 to the 4th power. but that's a lot of thinking. I think 4 to the second is perfect. 4 to the second is perfect. Okay, now we're going to simplify these expressions. So it's a to the 6th times a to the negative 5th. It's just like what we did last night. You combine, if it's the same base, the base stays the same. You combine the exponents. If it ends up negative, you've got to simplify that. So a to the 6th times a to the negative 5th. Is there somebody that hasn't gotten a ticket that wants to try this? Mason, what are you thinking? Okay, what are you supposed to do with those exponents when we multiply? We multiply, you keep the base, you don't multiply the exponents. What did we do?
-1.
So, what were you supposed to do to them? Add. So I have 6 and I lose 5. Is that -1? 6 minus 5, is that -1? A to the 1. So we could write a to the 1 or just a. Either one of those. Okay, what about number 9? R to the 7th over R to the 3rd. Now this is a division. Who hasn't gotten a ticket that wants to try this one? Caden up there, are you doing it? What would it be? R to the 4th. Since we haven't had one ending in a negative, I better do number 8. N to the negative 11th times n to the negative 2. Anybody want to try it? Okay, Liam.
So it would be a to the negative 14.
Negative 11 and negative 2.
Oh, I thought that was 3.
That's okay.
It would be n to the negative 13.
N to the negative 13, but we can't leave a negative, so then that would become what?
1 over n to the 13th.
1 over n to the 13th power. Good job. Questions?